Hello and welcome everyone. So I'll be explaining Codeforces round 770 division 2 problem B, fortune telling, one of the most mind-bending problems that I've ever encountered, and the solution is just awesome. Code is so simple to implement. So basically in this problem you're going to be given an array of n non-negative integers. You will have two players, Alice and Bob, and they will apply some set of operations, and the operation is that Alice will start if Alice starts with an integer x, then Bob will always start with an integer of Bob will have to start with an integer of x plus 3. Okay, now what is the operations? First of all, your goal would be to say which one of Alice or Bob, either Alice or Bob, would end up with a number y after applying some set of operations, of those operations. Now they've told us that exactly one of either Alice or Bob could have actually gotten that number. So either Alice or Bob would get the number. That is guaranteed. Both of them won't get the number y. Only one of them will get. Now, what is the operation? The operation is that you have to use every index of the array and in an increasing order, and for each index of array's value, what you could do is the number that Alice or Bob took earlier, he has the option to either add that number, that particular index's number, or XOR that. Now, that's exactly what the statement is actually applying. And finally, you have to output whether Alice or Bob would get the number y or not. Now, the problem, if we boil down to a sketch like that, we're gonna get, okay, this is my array, and let's assume that Alice will start with some integer x, and if you analyze a bit, you will understand that we could actually solve this problem on the perspective of Alice or either Bob. Now, I've solved this at the perspective of Alice. So if I solve it with the perspective of Alice, it's gonna we're gonna solve this like perspective of Alice only, meaning that Alice took the integer x. Now we're gonna solve our problem based on x. Now, if we don't somehow get the number y for some reason, I'll tell you the solution later, but you have to understand this. If we don't get an answer for Alice, then definitely the answer would be Bob, because the statement already told us that exactly one of Alice and Bob will get the answer. So if Alice does not get the answer, that's obvious that Bob will get the answer. So then the answer would be Bob. So we're gonna focus in terms of Alice to see whether he can get the integer y or not. Now, the question is, first of all, the operation clearly says that we're gonna have to use every index of the array. Now, each index I could make two operations. Either I could add or XOR. Now, there could be multiple of ways that there could be, like, how many number of ways that it could happen. For each index I have two choices, right? So overall it's going to be 2 to the power n. Each index I've got two choices, meaning one is if I could add, I could XOR. So I've got two choices, and I've got n indexes. So like overall choices would be 2 to the power n to come up. Now we don't have that much of space. We don't actually have that much of space, because n is up to 10 to the power 5. Now 2 to the power 10 to the power 5 is quite a big number. Now there could be multiple of those permutations. I could go any number of ways for Alice from x, whether I could make it y till y or not. So that way it will give us definitely time limit, and time limit exceeded, of course, for sure. Now we need to think differently, think out of the box. What we're actually allowed to do here, we're allowed to do XOR operations, and add additional operations. Now, if we analyze this a bit, what is this similarity between the general addition and XOR operations? What could be the similarities that we can find out? If we analyze a bit for two numbers, let's say one number is let's say 4, okay, and it's binary. Okay, let's take a new fresh page, and okay, let's take one number 4. It has the binary of 1 0 0, and let's take another number, let's say 7. We have 1 1 1. So the binary of 7 is 1 1 1, binary of 4 is 1 0 0. Now, if we apply general additional operations, what would that give me? 11, right? That would give me 11. Now, the question is, what is the binary of 11? Binary of 11 is 1 0 1 and 1, right? 1 0 and 1 1. Now, if we do an XOR operation, that's going to give us, let's say, 0 and 1, of course 1, 0 and 1, of course 1, 1 and 1. If I do XOR, it gives us 0, meaning we have a number of 2. So if I add 4 and 7, I'm getting 11. If I do an XOR operations between 4 and 7, it gives us number 2. Now, we don't find any similarities, right? Turns out, yes, we can. And where is that similarity? The similarity is inside the bitwise of those numbers. If you look at the bitwise numbers, first bit of 11 and the first bit of 2, you will see that they are the same, meaning that 0 1 1, actually it's 3, right? The binary, the XOR operations of 4 and 7 is 3, 1 1 is for 3. Okay, now if you look at it, you'll see that the first bit of these two numbers, whether or not the numbers are equal or not, but the first, take a look at the first bit. The first bit is the same, meaning they are of the same parity. And that is the most important observations in order to solve this problem, because no matter any number, it doesn't matter what number it is, if you add it and if you XOR those numbers, and if you try to see the first bit of those numbers, they will be equal. Meaning, what does the first bit of a number actually mean? It means their parity, whether it's even or not. If that would have been 0, then if we would do the XOR operation, that would have also given us 0 at the 0th bit. Meaning, no matter what number that is, if you add it and if you XOR it, their first bit or the first bit will be same, meaning their parity would be same. Okay, so that was like a really cool observation here. Their parity always is the same. Now, based on the parity observation, can we come up with a solution? Okay, I could show you another example. Let's take let's say this is number 4's binary, and let's take another integer. Let's take 1 0 1, 4 and 5. Now if I add 4 and 5, what does it give me? It gives me 9, conventional additional operation. Of course, it does give us 9, which is in binary 1 0 0 1. But 4 and 5, if you do an XOR operations, 1 0 0, meaning it does give us 1. But take a look at it. The first bit is always the same, meaning they are of same parity, which means no matter how many combinational operations you make in order to reach y from x for Alice, the number that you no matter how many combinations you make, the number that is gonna be the final number, forget about y. What's gonna be the number that's gonna be the final one after making those operations, whether it's XOR or normal addition, it doesn't matter. Doesn't matter if you use addition or XOR here and then XOR here and then addition, whatever the combination is. Ultimately, the number that it's finally gonna give us, let's say temp, its parity would always be the same for every combinations possible. Now, I hope I made you understand till now, because after that, the solution is really easy, because as we are told that only one of them will have the number y. So we know what is the number y. We're going to take that as an input, right? So if we know the number y, we could make the parity of it, whether it's even or not. And now the question is, if initial x that Alice takes was even, let's assume that, if that was even, and after applying the operations, no matter which combination it is, doesn't count, every combinational operation will give me ultimately the same parity. Let's say that number is temp. Let's say that number is temp. I'm counting on for Alice, okay? Only for Alice. Now, like Alice, let's say that the x that initially we're given is even, and after following the operation, any operations, you could make any. For conventional way, I just did all the sum operations. That's what I did for a conventional way, but you could do anything. It's always going to give us the same parity number, meaning the final value, let's say temp. Now, if temp's parity, meaning whether it's even or not, is equal to y, this number's parity, that means okay, let's assume that temp's parity is not equal to y's parity. Now what does that mean? That means any number of operations that we make and that we come up with a integer temp, its parity will not be equal to y, meaning if it's even, then it would be odd. If it's odd, then it would be even. So their parity is not the same, meaning ultimately we cannot get for Alice. I hope you understand what I'm trying to make. Whether if it's even, and after I make an operation and it gives me let's say an even number, but the y is always odd. Let's assume for that, for the sake of this example, but the y is always odd. So of course, what will Bob choose then? Now x was even. Now if x was even, then x plus 3 would always be odd, right? Let's assume that x was even, then x plus 3 will always be odd, meaning if that was odd, then that would always give me some odd number, that's for sure. Okay, so if I take in perspectives of Alice, I will say that, yeah, for Alice, when x was even after the operation, any number of operation, what is the parity? It's not equal to y, meaning it's not it does not get equal to y's parity, meaning that of course that Alice will never get the answer y. So who's going to get the answer? Of course Bob, because there will always have to be one person who's going to get the final answer. So it's going to be Bob. Let's say x gets an odd number, and after the operation, after applying all the operation, x gets an even, and y's parity is also even, meaning their parity is equal. Okay, let's say x let's say that x or d was like odd, and after the operation we get a parity of number even. and y is also parity of even. Now I'm claiming that, okay, if their parity is equal, then the answer would be Alice, because Alice will get the answer. Why is that? Because for odd number of x, we get an even number of parity, meaning x plus 3, as I've told you, plus 3 meaning the parity will change. So it was odd before, now it's going to be even. If I make an operation, I will see that I will always get an odd number for Bob. So it doesn't matter what it is, because the parity won't be same for from this odd, comparing with this odd to the y's even. So I hope I made you guys understand what the problem and the solution regarding that. And if I take you to the code section, it's really easy. Just make a sample operation, that is the sum of all the elements. Yeah, I could sum all the elements. That could be a valid operations. And of course, sum it with the initial x that you have taken, that Alice took, and checking the parity. If the parity is equal, Alice wins. If the parity is not equal, Bob wins, of course, always. Yeah, so yeah, I hope you guys understood the problem, the solution. Yeah, and don't forget to like, subscribe, and share. Till next time, goodbye.